Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss top 30 questions in Ray Optics and Optical Instruments. Okay, so in COMEDK, they are going to ask these kind of questions only. So if you are able to solve these 30 questions, definitely you will be able to counter these kind of questions in the exam, COMEDK exam. Okay, so let us start. The first question. A concave mirror of focal length f produces real image n times the size of the object. Here it produces real image, okay, and the size of the object is n times the size of the size of the image is n times size of the object, right? So the magnification of the concave mirror will be minus n, right? Okay, because it's real image, right? The distance of the object from the mirror is, we need to find the value of u, right? So now we know that m, that is magnification of the mirror, the concave mirror, m equal to minus v divided by u, right? M equal to minus n equal to minus v by u, so v equal to n into u, right? V equal to n into u. Okay, so now apply mirror formula. So 1 divided by f is equal to 1 by u plus 1 by v, right? So v equal to n into u, right? V equal to n into u. So now 1 divided by f is equal to 1 divided by u plus 1 divided by n into u. So take 1 by n into u to the other side. So 1 by u is equal to 1 divided by f minus 1 divided by n into u, right? Okay, so before that, before that, take 1 by u as common here. Okay, take 1 by u as common, so 1 by f equal to 1 by u into 1 plus 1 by n, that is n plus 1 divided by n. Okay, we need to find the value of u, right? So u is equal to f into n plus 1 divided by n. This is the distance of the object from the mirror. So the correct option is C. Okay. Question number 2. A double convex lens made of a material of refractive index mu1 is placed inside two liquids of refractive index mu2 and refractive mu2 indices mu3, and as shown mu2 is greater than mu1 is greater than mu3. A wide parallel beam of light is incident on the lens from the left. The lens will give rise to, again this one is also direct question, right? Apply lens maker's formula. So 1 divided by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. Okay, so here mu2 is greater than mu1 is greater than mu3. Mu1 is refractive index of the lens, right? So here the upper half has mu2 is greater than mu1, right? Mu2 is greater than mu1. So therefore here refractive index of the glass with respect to the mu2, that is mu1 divided by mu2 will be lesser than 1, right? Mu1 divided by mu2 will be lesser than 1, isn't it? The ratio will be, okay, the lesser than 1, right? So therefore this upper part behaves like a divergent or diverging lens, right? Diverging lens, isn't it? In lower part, mu3 is lesser than mu1, right? Mu3 is lesser than mu1. This is the upper part and this one is lower part. Mu3 is lesser than mu1, right? So therefore the lower part behaves like converging lens. Converging lens, right? Let's check each option. Option A says single convergent beam, wrong. Option B says two different convergent beam, wrong. Option C said two different divergent beams, wrong. Option D says convergent and a divergent beam, correct. So the correct option is D. Okay, we will get a convergent beam as well as divergent beam. Yeah. Question number 3. The angle of incidence for a ray of light at a refracting surface of a prism is 45 degree. Okay, this is the prism. normal. This is the incident ray. Angle of incidence is 45 degree. The angle of prism is 60 degree. Here the angle of prism is 60 degree. If the ray suffers minimum deviation through the prism, the angle of minimum deviation and refractive index of the material of the prism respectively are. Okay, here we need to find delta minimum and mu of the material. Okay, prism material. Let us find delta minimum, right? That is minimum deviation. What is the condition for minimum deviation? I equal to E, right? I equal to E and R1 equal to R2, right? So we know that the relationship between deviation and angle of prism and angle of incidence and angle of emergence, that is delta is equal to I plus E minus A. Here delta minimum will be 2I minus A. I is 45 degree, A is 60 degree. So angle of minimum deviation is 30 degree. 90 minus 60 is 30. So 30 degree, right? So option A and C are eliminated. Okay, let's check. Okay, let's find the refractive index of the prism. Here the refractive index of the prism, mu equal to sine of A plus delta m divided by 2 whole divided by sine of A by 2, right? A is 60 degree, right? And delta minimum is 30 degree. So 60 plus 30 is 90. 90 by 2 is 45. So sine 45 degree is 1 by root 2. So mu equal to 1 by root 2 and sine of A by 2 is sine of 30 degree, that is 1 by 2. Solve this, you will get root 2. So minimum deviation is 30 degree and refractive index is root 2. The correct option is D. Question number 4. A ray of light from a denser medium strike a rarer medium. Okay, a ray of light strike a ray of light from denser medium. Okay, this is the denser medium. Okay, strike a rarer medium. The angle of reflection is R and that of refraction is R dash. Okay, this is the angle of incidence, this is angle of reflection R. Okay, here, okay, so this is denser medium, right? So when light travels from denser medium to rarer medium, what happens? The refracted ray moves away from the normal, right? Like this. This is R dash. Okay, refraction is R dash. The angle of refracted ray makes an angle 90 degree with each other. The angle of here, the reflected and refracted ray makes an angle of 90 degree with each other. That is, this angle is 90 degree, right? The critical angle will be, okay, we need to find the critical angle, that is C, right? So what is the condition for the critical angle? Sin C equal to 1 by mu, right? Sin C equal to 1 divided by mu. Okay, so now here R plus 90 degree plus R dash is 180 degree, right? R plus R dash plus 90 degree is equal to 180 degree, right? So R plus R dash is equal to 90 degree, right? R plus R dash is equal to 90 degree. Now apply Snell's law at this point, right? So this is mu 2, okay? Here this is rarer medium, so mu 1. Apply Snell's law. So now mu 2 into sine I is equal to mu 1 into sine R dash. Okay, mu 1 into sine R dash. Here R dash is equal to 90 minus R, right? R dash is equal to 90 minus R. So now mu 2 into sine I is equal to mu 1, right? Mu 1 into sine R dash, right? Here rarer medium has refractive index 1, okay? So here, okay, let's keep it as mu 1 only. So mu 1 into sine of 90 minus R, sine of 90 minus R. right? So now mu2 into sin I is equal to mu1 into cos r, mu1 into cos r, right? So according to the laws of reflection, I equal to r, right? I equal to r. So now mu2 into sin I is equal to mu1 into cos I, right? So now sin I divided by cos I is equal to mu1 divided by mu2, right? So what is mu1 divided by mu2? Refractive index of the rarer medium with respect to the denser medium, right? That is 1 by mu, right? Here mu is equal to mu2 by mu1. Okay, 1 by mu will be mu1 by mu2, right? So tan I is equal to 1 divided by mu, right? Tan I is equal to 1 by mu. So this is sin C. Okay, so 1 by mu is sin C, right? Sin C is equal to tan I, right? Sin C is equal to tan I. In the options they are given in terms of r, right? Okay, I will write r, tan r. Okay, so this is tan r. So C, that is critical angle, C is equal to sin inverse of tan r, sin inverse of tan r. So the correct option is A, sin inverse of tan r. Okay. Question number 5. A ray of light incident normally on the first refracting face of the prism of refracting angle A. Okay, let us draw the diagram. Here, this is the prism. Angle of prism is A. Okay, and it falls normally on the first refracting surface. Okay, the ray of light comes out at grazing emergence. Here the angle of emergence is 90 degree. Okay, here this is the refracting ray. Okay, and this is emergent ray. Angle of emergence is 90 degree. Okay, if one half of the prism shaded portion, okay, is knocked off, the same ray will one part of the portion is knocked off. Again, let us redraw the diagram like this. Here refracting angle is A by 2, that is angle of prism. Okay, so this is angle of incidence 90 degree. So we need to find angle of emergence, right? Now apply Snell's law at this point, right? Okay, before that we know that R1 plus R2 is equal to A, right? R1 plus R2 is equal to A. R1 plus R2 is the angle between the refracted ray and the normal. Okay, angle between the refracted ray inside the prism and the normal. Okay, and R2 is angle between the refracted ray and the normal for second phase. Okay, yeah, here R1 equal to 0, right? R1 equal to 0, so R2 equal to A, R2 equal to A. Now apply Snell's law at this point. Mu into sin A, that is sin R2, R2 is A, right? Sin A is equal to mu1 is, okay, mu dash is 1, right? Refractive index of the air, 1 into sin 90 degree 1. So mu equal to 1 divided by sin A, right? Okay. Now second case, right? Again apply Snell's law at this point, right? So mu into, so what is the angle of incidence? Angle of incidence will be A by 2, right? R1 plus R2 equal to A by 2 for second case, right? R1 is equal to 0, so R2 equal to A by 2. So mu into sin of A by 2 is equal to 1 into sin E, right? Angle of emergence is E, sin E. So now sin E equal to mu is 1 by sin A, right? So sine of A by 2 by sine A. Sine A. Sine A. So I can write sine A as 2 times sine A by 2 and cos A by 2, right? So sine E is equal to sine A by 2 divided by 2 times sine A by 2 into cos A by 2. So now sine A by 2 will get cancelled, right? So finally E equal to sine inverse of 1 by 2, okay, sine inverse of 1 by 2 into 1 by cos A by 2 is secant A by 2. So the angle of emergence at an angle of, okay, emerge at an angle of emergence sine inverse of 1 by 2 into secant of A by 2. So the correct option is A. Okay. Question number 6. What is the radius of the curvature of double convex lens made of glass of refractive index 1.55 if its focal length is 20 cm? Apply lens maker's formula. 1 divided by f equal to mu minus 1 into 1 by r1 minus 1 by r2. Okay. So now mu is 1.55, right? Focal length is 20 cm. So 1 divided by 20 equal to mu is 1.55 minus 1 into r1 is equal to r, r2 is equal to minus r, right? So this will be 2 divided by r. So now solve this, you will get r equal to 22 centimeter. So the correct option is A. Question number 7. The given figure shows 3 cases of ray passing through prism of refracting edge A. The case corresponding to minimum deviation is. Okay, what is the condition for minimum deviation? The condition for minimum deviation must be R1 equal to R2, that is the refracting ray or refracted ray must be parallel to the base of the prism, right? So if you observe that in second case the refracting ray is parallel to the base of the prism, right? So second one is correct. Second one is correct. Okay. Question number 8. A convex lens is made of 3 layers of glass of 3 different materials. Okay, here the first material, second material and third material. As in the figure. A point object is placed on its axis. The number of image of the object are. Okay, we need to find the number of image of the object, right? Here we will get the number of image of the object as 1 only, right? Isn't it? Because all of them are combined, right? Isn't it? All of them are combined. So the number of the object, okay, number of the image will be 1 only. Okay, number of image of the object will be 1, right? So the correct option is C, right? The correct option is C. Question number 9. A ray of light suffers minimum deviation in equilateral triangle of prism P. Okay, it suffers minimum deviation, that is the refracted ray must be parallel to the base of the prism. Additional prisms Q and R of identical shape and of same material as that of P are now combined as shown in the figure. Okay, so the shape of the Q and R prisms are same as P and the materials is also same, right? So there will be no deviation, right? No deviation. No deviation. The ray will now suffer. Option A says greater deviation, wrong. Option B says no deviation, correct. Okay, option C says the same deviation as before. Okay, the same deviation as before, not no deviation. Same deviation as before. Okay, option D says the total internal reflection, wrong. So the correct option is C. Okay. Question number 10. In a laboratory, 4 convex lenses L1, L2, L3 and L4 of focal length 2, 4, 6 and 8 centimeter. Okay, L1 L2, L3 and L4, right? Here 2, 4, 6, 8 centimeter respectively are available. Two of these lenses from telescope of length 10 centimeter and magnifying power 4. Okay, length of the telescope is objective focal length plus eyepiece focal length, right? And magnifying power of the telescope is objective focal length by eyepiece focal length. Okay, so L equal to 10 centimeter, right? So 10 equal to FO plus FE and 4 equal to FO by FE. The objective and eye lenses are respectively. Okay, we need to find here, we need to find the focal length of the, okay, we need to identify which lens they are using. Okay, in laboratory, which what are the lenses have used. Okay, what are the lenses have used. Okay, let us find FO and FE, right? Yeah, because the focal lengths of the L1, L2, L3 and L4 are given, right? So now FO equal to M into FE. So now substitute FO to the first equation. So 10 equal to FO is M into FE. M is 4 times FE plus FE. So FE is equal to 4 plus 1, 5, right? So 10 divided by 5, which is equal to 2 centimeter. Okay, so we are using the first lens as eyepiece. Okay, we are using first lens as eyepiece. So let us find FO. So FO is M into FE, right? So FO is equal to 4 into FE, that is 2 centimeter. So FO equal to 8 centimeter. So we are using L4 as objective lens, right? We are using L1 as eyepiece and L4 as objective lens. Okay, L1 and L4. The correct option is B. Okay, so what they are asking, objective and eye lenses, right? Okay, objective is 8 centimeter, eye lens is L1. So L4 and L1, not L1 and L4. Okay, L4 and L1. L4 and L1. Option D is the correct answer. Question number 11. In a telescope of focal length 20 centimeter, magnification 9FO and FE respectively. The same kind of question, right? Okay, we know that magnification of the telescope M is equal to FO by FE, right? FO by FE. Here the magnification is 9FO, right? In a telescope length 20 centimeter, magnification 9FO and FE are respectively. So we need to find FO and FE. Magnification is 9, okay? Magnification is 9. FO and FE are respectively. We need to find the value of FO and FE, okay? Not 9FO, it is 9. So 9 equal to FO divided by FE, right? 9 equal to FO by FE. So FO is equal to 9FE. The same kind of question, right? Here they have, here they just changed the values, right? Here they have just changed the values. So now FO equal to 9 into FV, length of the telescope L equal to FO plus FE, right? So now L equal to 9FE plus FE, that is 10 FE. L is 20 centimeter, so FE is equal to 20 by 10, that is 2, right? FE equal to 2 centimeter. Okay, we got the value of FE. Let us find FO. Here FO is equal to 9 into FE, right? So that is 9 into 2, 18 centimeter. FO is 18 centimeter, FE is 2 centimeter. So the correct option is A. Okay, in centimeter. Question number 12. When sunlight is scattered by atmospheric atoms and molecules, the same amount of scattering of light of wavelength 440 nanometer is A. Okay, we know that the scattering is directly proportional to or inversely proportional to 4th power of wavelength, right, or wavelength of the light. The amount of scattering for the light of wavelength 660 nanometer is approximately. Okay, when the wavelength of the light is 440 nanometer, the scattering is A, right? So IS is equal to, sorry, IS is directly proportional to, okay, IS is directly proportional to, here scattering of light of wavelength 440 nanometer is A. So 1 by 440 nanometer to the power 4. So this is A, right? So this is equal to A, isn't it? So now IS dash is directly proportional to 1 divided by 660 nanometer to the power 4. Okay, so which is equal to A dash. So now divide second equation by the first equation. Okay, so A dash divided by A is equal to 440 divided by 660 to the power 4. So 10 will get cancelled. Now 22 3s are 66, 22 2s are 44. So now A dash divided by A is equal to 2 divided by 3, right? So now A dash by A, okay, whole to the power 4 is there. So 2 to the power 4 is 16. 16 divided by 81, okay, 16 divided by 81. So 16 by 81 is 0.66, right? So which is approximately equal to 0.66, right? So A dash is equal to 0.66 times A. 0.66 times A. So the correct option is D. Okay, correct option is D. Question number 13. The radius of curvature of a concave mirror is 24 centimeter and the image is magnified by 1.5 times the object distance is. Okay, so M equal to 1.5, right? M equal to 1.5. So the magnification M equal to, here we have used concave mirror, right? So image formed by the concave mirror is always real and inverted, right? So magnification will be minus 1.5, right? So magnification M equal to minus V divided by U. So V equal to 1.5 times U, right? So we need to find object distance, that is U. Apply mirror formula, 1 divided by F is equal to 1 by V plus 1 by U. Radius of curvature of the concave mirror is 24 centimeter. So R equal to 24 centimeter. We know that focal length of the concave mirror is always negative. So focal length F equal to minus R by 2, that is minus 12 centimeter, right? Minus 12 centimeter. So here apply lens formula. So 1 divided by F, F is minus 12 centimeter is equal to 1 divided by U. U is U only, right? We need to find U, plus 1 divided by V is 1.5 times U. Now minus 1 divided by 12 centimeter, right? 1 divided by 12 minus 1 by 12 is equal to, take 1 by U as common. So this will be 1.1 plus 1 plus 1 divided by 1.5, that is 2.5 divided by 1.5, right? Now U is equal to minus 12 into 2.5 divided by 1.5. So 0.53s are 1.5. 0.53s are 1.5, 0.55s are 2.5, right? So now 3 4s are 12, 4 into 5 is 20. So U equal to minus 20 centimeter. So what is the meaning of negative sign? The negative sign indicates that object placed in front of the concave mirror, right? That is the measurement of U, the direction of the measurement of U is opposite to the direction of the incident ray. So the correct option is A. Question number 14. The refractive indices of glass and quartz with respect to air are 3 by 2 and 12 by 2 12 by 5 respectively. Okay, refractive index of the glass with respect to air is 3 by 2 and refractive index of the quartz with respect to air is 12 by 5. The refractive index of the quartz with respect to glass. So refractive index of the quartz with respect to glass, right? So which is equal to refractive index of the quartz divided by refractive index of the glass, right? So refractive index of the quartz is refractive index of the quartz with respect to air, right? Refractive index of the quartz by refractive index of the air into refractive index of the here divided by refractive index of the glass, right? That is refractive index of the glass by refractive index of the air. So I can write it as refractive index of the air divided by refractive index of the glass, okay, which is equal to, so what is the refractive index of the quartz with respect to the glass, with respect to the air? 12 by 5, 12 divided by 5. So what is the refractive index of the glass with respect to air? 3 by 2. So mu A by mu J will be 2 by 3. So 2 divided by 3. So 3 4s are 12, 4 into 2 is 8, so 8 by 5. So the correct option is A. Okay. Question number 14. The radius of curvature of the convex face of a plano-convex lens is 15 centimeter. Okay, so this is the plano-convex lens. Radius of curvature of this radius of curvature of the convex face of the plano-convex lens is 15 centimeter. R equal to 15 centimeter. And the refractive index of the material is 1.4. Then the power of the lens in diopter. Okay, we know that power of the lens is equal to the reciprocal of focal length of the lens, right? So let us find the reciprocal of focal length of the lens. Let us find the focal length of the lens, right? Apply lens formula, lens maker's formula. So 1 divided by f equal to mu minus 1 into 1 by r1 minus 1 by r2. R1 equal to r, okay, so this is r1. R2 is equal to infinity, right, because of the plane surface. R2 is equal to infinity. R1 equal to positive r. Why? Because the measurement of r1 is same as direction of the measurement of r1 is same as the direction of the incident ray. So now 1 divided by f, okay, so 1 divided by f is equal to mu, that is 1.4. 1.4 minus 1 is 0.4. So 0.4 into 1 by r1, right, that is 1 by r. 1 by r is 1 by 15, okay, 1 by 15. Now f, so 1 by f equal to 0.4 divided by 15, right? So p equal to 0.4 divided by 15. So this is 1 by f, okay, 1 by f. P equal to 0.4 by 15, right, 15 centimeter, right? Centimeter is 10 to the power minus 2, right? So P equal to 0.4, 1 by 10 to the power minus 2 is 100, right? 100 divided by 15. So now 15, so 5 3s are 15, 5 20s are 100, right? So P equal to, so this will be 8, right? So 4 into 20, right? 4 into 20 is 80. 8 into 10 to the power minus 1 is 8. So 8 divided by 3, right? So 8 divided by 3, 3 1s are, 3 2s are 6, right? So 2.66. So power of the lens is 2.66 diopter. So the correct option is D. Question number 16. A boy of height 1 meter stands in front of a convex mirror. Okay, the boy here the height of the boy is 1 meter and he stands in front of the convex mirror, right? His distance from the mirror is equal to the focal length. Okay, so u equal to minus f. The height of his image is, so we know that magnification of the mirror, magnification of the convex mirror, m equal to minus v by u, right? Minus v by u. And we also know that magnification is height of the image by height of the object, right? Height of the image by height of the object. So u equal to minus f, right? the focal length of the convex mirror is f. So let us find v, right? So apply mirror formula, 1 divided by f equal to 1 by v plus 1 by u. So u equal to minus f, right? So 1 by f is equal to 1 by v minus 1 by f. Now 1 by v is equal to 1 by f plus 1 by f, that is 2 by f, right? So 2 by f is f by 2, right? V equal to f by 2. V equal to f by 2. V equal to f by 2. So now here minus v by u, that is f divided by 2 divided by minus of f divided by 2 divided by u is minus f, is equal to height of the image, that is height of the image of the boy, okay, divided by height of the object, that is height of the boy, that is 1 meter. So f will get cancelled, minus into minus is plus, right? So height of the image is equal to 0.5 meter, 0.5 meter. So the correct option is C. Question number 17. An object is placed at a distance of 1.5 meter from a screen and a convex lens is interposed between them. Okay, so this is the object, this is the screen, and the convex lens is placed between the screen and the object. The distance between the object and the screen is 1.5 meter. That is v plus u is equal to 1.5 meter. The magnification produced is 4. Here we have used the convex lens, right? So convex lens produces real image and inverted image. So m equal to minus 4, right? M equal to minus 4. So m equal to v by u equal to minus 4. So u equal to minus v divided by 4. U equal to minus v by 4, right? So the focal length of the lens is, okay, we need to find the focal length of the lens. So let us find u and v, then apply lens maker's formula. Okay, so now u equal to minus v by 4. Okay, so v plus u equal to 1.5, right? That is magnitude of v plus magnitude of u is equal to 1.5 meter, right? 1.5 meter or 150 centimeter. Okay, 150 centimeter. U equal to v by 4. In magnitude it is v by 4. So v plus v by 4 is equal to 150 centimeter, right? So now v plus v by 4 is 5 v by 4, which is equal to 150 centimeter. So now 5 3s are 15, then 0. So 3 into 4 is 12, right? So this is 120 centimeter. So v equal to 120 centimeter, right? V equal to 120 centimeter. V equal to 120 centimeter. And what is the value of u? U will be equal to minus v by 4, that is minus 120 divided by 4. Minus 120 divided by 4 is 30. So minus 30 centimeter. So now apply lens formula, that is 1 divided by f is equal to 1 by v minus 1 divided by u. Okay, so 1 divided by f is equal to 1 divided by v, that is 1 divided by 120 minus 1 divided by u. U is minus 30 centimeter. So 1 divided by 30. So take 1 by 30 as common. So 1 by f equal to 1 by 30 into 1 plus 1 by 4, that is 5 by 4. 5 divided by 4, right? So 5 6 are 30. So 6 into 4 is 24. So f equal to 24 centimeter. So in meter this is 0.24. So the correct option is C. Question number 18. A concave mirror gives an image 3 times as large as its object placed at a distance of 20 centimeter from it. For the image to be real, the focal length should be. Okay, so the image is real. So we need to find the focal length of the mirror, right? So here the focal length of the mirror is anyway it's negative, right? Okay. So the magnification of the concave mirror m equal to minus v divided by u, right? Minus v by u. Here object distance is given 20 centimeter, right? So we need to find the focal length. So we know that mirror formula 1 divided by f equal to 1 by v plus 1 divided by u, right? So 1 by v is equal to 1 divided by f minus 1 divided by u. So 1 by v is equal to here f minus u divided by uf, that is u minus f divided by uf. So v equal to here u into f divided by u minus f, okay, u into f divided by u minus f. So now substitute here m equal to minus of v is uf divided by u minus f whole divided by u. So u will get cancelled. M equal to minus of f divided by u minus f, okay, minus of f divided by u minus f. Here the concave mirror gives an image 3 times as large as its object placed, that is m equal to 3, right? M equal to 3, isn't it? So now 3 is equal to minus f, okay, or you can write it as f divided by f minus u, f divided by f minus u. U is 20 centimeter, okay, minus 20 centimeter, okay, so this will be plus 20. So now f 3f plus 60 is equal to f, right? 3f plus 60 is equal to f. So minus 2f is equal to 60, minus 2f equal to 60. So f equal to minus 30 centimeter. So concave mirror has negative focal length, right? Isn't it? So that's why it's negative 30 centimeter. So the correct option is D. Okay. So you will get plus 30 centimeter if you take the sign convention here. Okay. From this formula only, you will get the positive 30 centimeter. But I didn't take here. Okay. Question number 19. Two convex lenses A and B placed in contact from the image of a distant object at P. If the lens B is moved to the right, okay, lens B is moved to the right a little, the image will. Okay, so the lens B is moved to the right little, right? Isn't it? That is, the distance between A and B increases, right? So distance between A and B increases. So let us write the formula, right? So when the two lenses are separated by small distance, so the combination of the focal length will be 1 by f equal to 1 by f1 plus 1 by f2 minus d divided by f1 into f2, right? So if you increase the distance, what happens? The focal length of the combination will be decreases, right? So the focal length of the combination will be decreases. We know that 1 by f equal to 1 by v minus 1 by u. So if f decreases, right? If f decreases, u value remains same, right? Okay, let's write here v is equal to 1 by f plus 1 by u, right? So 1 by f plus 1 by u, that is uf divided by u plus f. If the value of f decreases, then v will also be decreases, right? Isn't it? That is, the image distance will also be decreases. Okay, so when here f decreases, what happens? Here u will also be decreases, isn't it? If f decreases, that is combination of the lens decreases, what happens? Here the u value will also be decreases because it is moving towards the object, right? So u value is also decreasing, isn't it? So v value will also be increases. If you move towards the object, if you move the lens B towards the object, what happens? The image distance will also be decreases, right? So that is, image will move to the right, isn't it? The image will move to the right. So the correct option is B. Okay, so the correct option is B. Yeah. So next question, question number 20. A equilateral, okay, a equiangular glass prism. Equiangular glass prism means equilateral triangle. Okay, 60 degree, 60 degree, 60 degree. Of refractive index 1.6 is kept fully immersed in water of refractive index 4/3. Okay, refractive index of the prism is 1.6 and refractive index of the water is 4/3. For a certain ray of monochromatic light, what is the closest value for angle of minimum deviation of the ray in this setup? Takes sine E. Okay, sine of 37 degree is equal to 0.6. Okay, so here we need to find the angle of minimum deviation, right? Okay, so refractive index of the prism is given, right? Isn't it? Refractive index of the prism and refractive index of the water is given. So what is the refractive index of the prism with respect to water? Refractive index of the prism with respect to water, which is equal to mu. So which is equal to 1.6. 1.6 divided by 4/3. So now mu is equal to 4.8 divided by 4. So this will be 1.2. Mu is equal to 1.2. Okay, yeah. So now apply the prism refractive index of the prism formula, mu equal to sine of A plus delta minimum divided by 2 whole divided by sine of A by 2. Sine of A divided by 2. So angle of the prism is 60 degree, right? Angle of the prism is 60 degree. So mu equal to 1.2. So 1.2 is equal to sine of 60 by 2 is 30. So sine 30 degree plus delta m divided by 2 whole divided by sine 30 degree. Sine 30 degree. So now 1.2 is equal to sine of 30 degree plus delta m divided by 2 whole divided by 1/2. Okay, so 1.2 by 2 is 0.6, right? So 0.6 0.6 into, okay, so this will be 0.6 equal to sine inverse of 30 degree plus delta m divided by 2, right? So sine inverse of 0.6 is 37 degree, right? So 37 degree, okay, so 37 degree is equal to 30 degree plus delta m divided by 2, right? So now solve this, you will get delta m equal to 14 degree. This is the angle of minimum deviation. Okay, delta m equal to 40 degree. 14 degree. So the correct option is B. Correct option is B. Question number 21. All lights are switched off except for a bright point light source kept at the bottom of a swimming pool filled with clear water of refractive index 4/3. As a result, only a circular patch of 6 meter diameter of water surface is visible to the spectators. Okay. Here this is the point source, right? So refractive index of the water mu is equal to 4/3, right? Mu equal to 4/3. So now the diameter is 6 meter. So the radius will be 3 meter. Okay. So why it happens? So, okay, beyond 3 meter, okay, beyond this, the light is not visible, right? Because the total internal reflection takes place, isn't it? So here, this angle has to be critical angle. So this angle will also be critical angle, C. Okay, spectators standing around the swimming pool, which of the following gives the depth of the pool? Okay, we need to find the depth of the pool, right? That is D. Okay, depth of the pool. Okay, so the diameter is given. So the radius is 3 meter, right? And refractive index of the water is also given, right? So refractive index of the okay, here this is the critical angle, right? So sin C is equal to 1 by mu, right? Sin C is equal to 1 by mu. So mu is 4 by 3. So sin C will be 3 by 4. Sin C will be 3 by 4, isn't it? So what is 3? Height. 4 is here 3 by 4, right? Isn't it? Sin C is 3 by 4. Okay. So now here this is the right angle triangle. Okay. So this is C. Okay. This is C. Here this is height 3 and the hypotenuse is 4, right? So now sin C is equal to radius, square of the radius, okay, r divided by, here r divided by the base will be, sorry, r divided by hypotenuse will be r square root of r square plus d square, which is equal to 3 by 4. So now take square on both side, okay? So now r square divided by r square plus d square is equal to 9 divided by 16, right? 9 divided by 16. So now here r is 3 meter, right? So now r square divided by, sorry, r square plus d square divided by r square plus d square divided by r square is equal to 16 by 9, right? So now here r is 3 meter, so 9 plus d square divided by 9 is equal to 16 by 9. So 9 will get cancelled. 16 minus 9 is 7. So d square is equal to 7. So d equal to root of 7 meter, right? So root of 7 meter. So root of 7 meter is approximately equal to 2.6 meter. So the correct option is C. Question number 22. If A is the angle of prism, angle of refraction, then the condition for minimum deviation. If A is the angle of prism, R is the angle of refraction, what is the condition for minimum deviation? The condition for minimum deviation is angle of prism must be equal to, here R1 must be equal to R2. So this is the condition for minimum deviation. We know that A equal to R1 plus R2, right? So A equal to R1 plus R2, R1 equal to R2, so this will be 2 times R. Okay, R1 equal to R2 equal to R, so A equal to 2R. So the correct option is B. Question number 23. A concave mirror forms an enlarged erect virtual image. Concave mirror forms an enlarged erect and virtual image of an object only when the object is placed. When the object is placed between the focal length and the pole, if object is placed between focal length and pole, we will get the enlarged erect and virtual image by the concave mirror. So the correct option is B. Question number 24. A man stands symmetrically between two large plane mirrors fixed to two adjacent walls of rectangular room, like this. The angle between the two plane mirrors is 90 degree. Okay, he stands symmetrically. That is, angle between this line and the first plane mirror is 45 degree and the second one will also be 45 degree, right? The number of images formed are, simple one, right? Use this formula. The number of images formed, n equal to 360 degree minus theta minus, 360 degree divided by theta minus 1, right? So what is the value of theta? Theta is angle between the two plane mirrors, 90 degree. So n equal to 360 by 90, that is 4 minus 1, which is equal to 3. The correct option is B. Correct option is B. Question number 25. A ray of light falls upon a 60 degree prism. Angle of prism is 60 degree. Refractive index of the prism is √2 and it suffers minimum deviation. The angle of incidence for ray must be. Okay, so it suffers minimum deviation, right? Refractive index of the prism is also given. So let us find angle of minimum deviation. Then we can easily find the angle of incidence, right? So refractive index of the prism mu is equal to sine of a plus delta m divided by 2 divided by sine of a by 2, right? So now mu is equal to, here a is 60 degree, right? So sine of 30 degree plus delta m divided by 2 whole divided by sine of a by 2, that is sine 30 degree. Sine 30 degree is 1 by 2. Here mu equal to root 2. Mu equal to root 2. So now sine of 30 degree plus delta m by 2 is equal to 1 by 2 into root 2, that is 1 by root 2. 1 by root 2. Then sine inverse of 1 by root 2 is pi by 4 or 45 degree. 45 degree minus 30 degree is 15 degree. So delta m by 2 is equal to 15 degree. So delta m equal to 30 degree. So angle of minimum deviation is 30 degree, right? So we know the relationship between angle of deviation, angle of incidence, angle of emergence and angle of prism. So what is the relation? Delta equal to I plus E minus A. So what is the condition for angle of minimum deviation? I equal to E, right? So now delta m is equal to 30 degree. Delta m equal to 30 degree, right? So 30 degree is equal to 2I minus A is 60 degree, right? So now 2I equal to 90 degree. So I equal to 45 degree. Angle of incidence must be equal to 45 degree. So the correct option is B. Correct option is B. Question number 26. The reddish appearance of the sun at sunrise and sunset due to the scattering of light, right? That's it. Due to the scattering of light. Okay. The direct question. Question number 27. The two plane mirrors are inclined at 70 degree. Okay. Two plane mirrors are inclined at 70 degree. A ray incident on the one mirror at an angle of theta, at an angle theta. Here a ray, so this is the ray, angle of incidence is theta. After the reflection falls on second mirror and is reflected from there parallel to the first mirror. Okay. So then parallel to the first mirror, right? So this angle is 70 degree, right? Now here 70 plus theta is equal to 90 degree. So this angle is theta, right? Sorry, this angle is something theta dash. So 70 plus theta dash is 90 degree. So theta dash will be 20 degree, right? So this angle will also be 20 degree because angle of incidence is equal to angle of reflection, loss of reflection, right? The value of theta. Okay, so this angle is 20 degree, isn't it? So this angle is 20 degree. So the total will be 40 degree, right? Here the angle is 70 degree, right? Angle is 70 degree. So what about this angle? So this angle will also be 70 degree, right? So the total angle is 90 degree, right? So this total angle is 90 degree. So 90 minus 20 is 70. So this is 70 degree, right? So the total interior angle is 180 degree. 70 plus 70, 140. 180 minus 140 is 40. So this angle is 40 degree. Here the total angle is 90 degree, right? Total angle is 90 degree. So 90 minus 40 is 50. So here the reflected ray is 50 degree. According to the laws of reflection, angle of incidence is equal to angle of reflection. So the value of theta is also equal to 50 degree. So the correct option is C. Question number 28. A convex lens of focal length f is placed in contact with the concave lens of focal length f. The equivalent focal length of the combination. The direct question, right? You don't need to solve this on paper, right? So we know that combination of the focal length 1 by fc is equal to 1 by f1 plus 1 by f2. f1 equal to f f2 equal to minus f, because the concave lens has negative focal length. So 1 by fc is equal to 1 by f minus 1 by f, that is equal to 1 by infinity, right? So 1 divided by, sorry, this is equal to 0. Okay, so this is equal to 0. So the value of combination of focal length will be infinity. So the correct option is A. Okay, so it behaves like a plain glass, right? Yeah. Question number 29. A monochromatic ray of light enters a glass slab, refractive index 1.5, along the normal to the surface, the angle of deviation of the refracted ray. So this is the interface between the air and glass slab. So this is how the incident ray falls on the glass slab. Angle of incidence is 0 degree, right? So apply Snell's law at this point. Mu into sin I is equal to mu dash into sin r. Mu dash is n, that is 1.5. I is 0 degree, sin 0 degree is 0. So angle of refraction r will also be equal to 0 degree. So the correct option is D. Okay. And the last one. A ray of light passing from glass to water is incident on the glass water interface at 65 degree. Okay, a ray of light passing from glass to water, okay, glass to water is incident on the glass water interface at 65 degree. 65 degree. If the critical angle for the pair of media is 63 degree, okay, C equal to 63 degree, right? C equal to 63 degree, that is this ray undergo total internal reflection, right? Because the angle of incidence is greater than critical angle, so it will undergo total internal reflection. Okay, let's see. The ray will emerge into water with a deviation 2 degree from the normal. Wrong. Option B, the ray will be refracted into water with a deviation of 2 degree. Wrong. The ray will be totally internally reflected back into the glass with a deviation of 50 degree. Okay, so now it is not a angle of deviation is not a 50 degree, right? Angle of deviation must be equal to 2 degree, isn't it? Option D, the ray will be totally internally reflected back in the glass with a 2 degree, right? Here angle of deviation must be equal to 2 degree, right? Because critical angle is 63 degree, angle of incidence is 65 degree. So the deviation will be 2 degree, right? So the correct option is D. That's it. Okay. Thank you so much for watching this video. Okay, if you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.